All right, I want to introduce Mission Planner to you guys and talk about what it does and how we're going to use it when we go out in the field and do our mapping. So Mission Planner is an open source application that works with the APM and the Pixhawk flight controllers and I think a few others. And it's what we're going to have on a laptop when we're out in the field. And it's going to be the second way of us being able to track where the drone is going and control it. And it'll be where we establish our flight parameters, all the waypoints that we use to do mapping. So you may need to go to the website and install it. I don't know if we have it on our machines yet, but when you first open it up, actually this is what you're going to see is the flight data screen. And what we're going to do is connect to the Solo with it, and you'll do that by clicking on the connect button over here. And there'll be some specifics on how to do that correctly that I'm not going to go through for the video. So just to give you an overview of what Mission Planner is and how we're going to use it. There's some components of it that are meant to be used to set up your drone, and that's mostly the initial setup here, that once you connect, there's a bunch of options to configure your drone and to tune it. We may deal with that a little bit in class, but for the most part, we'll be using this in the field as our ground control station. Some other settings here for doing the tuning. Again, when you're connected, there's going to be a lot more options that appear once Mission Planner knows what kind of drone you're working with. And we're mostly going to look at the first two, if you think of these as tabs or functions. The flight data screen, this is going to be where we get real-time information from the drone as it's flying around. We're going to have our artificial horizon. We can kind of see the orientation of the drone, its battery state, information about its GPS connection, any errors that might occur. If there's too much vibration, for example, that'll come up. We'll also see its altitude, its ground speed. We'll also be able to change flight modes. So one of the things that we'll do is we'll switch to actions here, and these are different flight modes that we can switch into and out of. So for our telling the drone to start mapping, we're going to be clicking on this auto button, and that'll have Mission Planner, or actually the flight controller on the drone, take over flying the drone itself. There's a few other hidden tools in here that we'll use later, the telemetry logs and the information, the data logs that are on the drone. So if we had a crash and we needed to do some analysis about why that would occur, we'd be downloading the data flash logs and looking at vibration and other things and errors that are on the drone. And generally, we don't need that. We will need the flight logs in order to align our imagery with where the drone actually was at any given point in time. And we'll do this using this telemetry log tool. So, but for the most part, we'll use this while we're out in the field. We'll get a map here that will show us where the drone is at any given point in time, and kind of make sure that's in the right place, and so forth. We will also use this tool to figure out how to fly, where to fly. We'll do most of that in our flight planning. And it grabs maps from Google satellite imagery. Now, one thing to note is that on our laptop, we're not going to have access to the internet, so it's always good while we're still within Wi-Fi to pull up a lot of these maps, and Mission Planner will cache them on the laptop. So when we get out in the field, we'll have all the detailed maps, and to zoom in a couple different scales so that we've got detailed maps in the field. So let's just imagine that we're going to map this field here. And so we might do a few things in advance. We may define kind of our study area before we get out in the field and go through a couple mission scenarios to get a sense of how long it's going to take to map this. And then we'll wait till we actually get out in the field before we finalize this, because we need to know the wind direction and speed before we set some of this. So in this map planning tool, by default, it allows you to establish waypoints. So if I just start clicking around, it's going to establish waypoints that it would fly to. And as you add these waypoints, it generates a kind of a program down here at the bottom. So we can look at all the waypoints that we've added, where they're going to, and then this wouldn't do anything on the drone until I upload them. So I would have to go over to the right, say write waypoints, and then it would write this to the drone, and then I'd have to be in auto mode before it would actually run this program. So in auto, it's going to run whatever program we've put on it. So you could generate a flight plan manually, and we're going to use a little bit more sophisticated tools to do this. So I'm going to right click here, and a lot of the tools I'm going to need are on the right mouse button menus. I'm going to clear that mission, and then I want to create a boundary that I want to go out and map. So I'm going to right click here and say draw polygon and add polygon point. Okay, you remain in this polygon mode until you clear the polygon or blah 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 blah. Okay, so this allows me to define the boundary of what I'm going to fly. So I'm going to create and digitize a polygon and say, all right, that's the area that I'm going to map. Now, it's generally a good practice to right click and to save that file off into the desktop. So, all right, that's our study area. Because I'll probably want to fly the same thing again, or go back and see what I established as a study area, and it doesn't get saved by default. So it's a good idea to save that. And then let's do a scenario to get a sense of how long it's going to take to fly this area. So I'm going to right click again, and I'm going to go down to auto waypoint, and we're going to use the create survey grid. This brings up another tool that allows me to see the flight lines that this tool automatically creates in order to fly that area. And initially here, it's defaulting to an altitude of 100 meters, flying speed of 5 meters per second. It's adding auto takeoff and landing, so RTL, or return to launch. And it's saying at these current settings, this would take 4 minutes and 46 seconds, so almost 5 minutes to fly that. So plenty, easily done within our flight time of the Solo. But that's kind of high. That's usually a little higher than we would fly, and we haven't specified the camera yet. So we need to pick the camera that we're actually going to use. We're mostly going to be using a Sony, and that's about the same thing as this Sony Nex 7 16 millimeters. Later on we'll customize the camera, and then we typically fly either at 80 meters or 50 meters, and we fly at 8 meters a second. So at that setting, I'm down to just 2 minutes and 57 seconds, so plenty of time again. So I could probably get away with flying a little bit lower, getting more detailed imagery. Obviously, the lower I fly, the higher resolution my imagery, or the smaller the pixel size. Okay, so there's my mission. Later on, we'll talk about how to modify this a little bit. We're in the simple mode right now. For the most part, we're going to use the more advanced mode. So that's down here, the advanced options, and look at some of these other options here. And probably actually we should do that now. So I'm going to look at grid options here. We're going to up the overlap. So this is right now just a 50% overlap. So think of the imagery here and overlapping back and forth. That we want that to be a little bit higher for our orthomosaic and the creation of a three-dimensional model. So we're going to go up here. I'm just going to type in 70% and my side lap 70%. And that, of course, will mean that our flight lines have to be a little bit closer. And now I'm up to 5.5 minutes in order to survey this whole area. All right, and in the field, we're going to orient these flight lines at 90 degrees or perpendicular to the wind. So this would work as long as the wind was coming either out of the northwest, or southeast, and that way that the speed of the drone along each flight line will be fairly consistent. We'll also orient our grid so that we'll start in a corner that's away from us and fly closer to where we land, where we're taking off and landing. So if our starting point was here on the southern end, I'd want to make sure that I'd want to start far away and get closer. And we can do that. So if that was the case, and let's say the wind was out of the south, so we're going to want to go far away and come back towards us. I go to grid options, and I think start from, let's say, the top right. Okay, so it's going to fly up here first and then go this way towards us. And again, that's a matter of making sure that if we run out of battery, that we're relatively close to home, and we're not trying to return the drone when it's really far away from us and it might run out of battery before it gets back. So a couple reasons we're doing that: for safety and for consistency of the mapping. Okay, so I've messed around with this. Again, I've confirmed the flight time. You're going to need to record this on your data sheet, your flight sheet, because it kind of disappears and it's hard to get back once it's done. And then I'll go back to the simple and say accept. Now it adds this to my flight plan. And again, if I look down here at the bottom, in my series of waypoints, I've got the full program. And it will start with taking off, flying to a particular location, and then this do set, this is the camera trigger. If we had our camera connected directly to the flight controller, this would trigger the camera at a certain distance. That's preferable, but we don't have that working yet. So even though these commands are here, they won't hurt anything to be there. And at the very end, we notice that it's got an RTL, a return to launch. So this thing will come back and try to land by itself. And that's where in practice we're taking over in the last 5 or 6 feet, last 10 feet, in order to land manually. So I confirm that this is right, and then once I'm connected, I will hit the right waypoint button, and those waypoints will be written to the drone. And then later on, when we're in the flight data mode, flight mode, we'll switch to actions, and when we click the auto button, it will run that program. What I want you to do before class time is to play around with the software a little bit, get a sense of how it works. When we're out in the field on the laptop screen's a little bit harder to look at, so you kind of need to know where you're going. In harsh lights, it's hard to see some things. And I want you to practice making some missions here. So find a place to map and start messing around with creating your own survey grid that we'll use for mapping later. All right, good luck, and we'll try this out soon. Thanks.